Okay, please scan the QR code if you haven't scanned. We'll start maybe in 2 or 3 minutes. And for the announcement, next week we will have quiz. Okay, Monday next week. Next week, Monday. It will be about the function and limit. Okay? Function and limit, chapter 1, chapter 2. Okay, please scan the QR code. And for the online students, I will send you an email to explain the quiz. Okay, so it will be from chapter 1, functions and limits. Okay, I think we can start now. Okay, I think last week we discussing about the product rules, and I haven't finished proving the theorem for the product rules. So I will today start with product rules, quotient rules, and maybe some of the examples for functions for derivatives. Okay. By the way, how's your weekend? Holiday, long weekend, right? Good. Very good. And you have also another long weekend this week. But don't forget, Monday you have quiz, okay? Okay, for product rule, let me just write the big F of X is, for example, if you have functions multiplied by other functions, okay, and you define those two functions in another function, which is F, the big F here, the big capital F, okay. Then I can write this derivative in our limit definitions. Okay. And then we can change all the functions into F and G. So the big F will be converted. Okay, and to prove the theorem and to solve this limit, okay, to solve this limit, we need to add and subtract some expression. Okay, so add and subtract. So plus and minus, okay, plus and minus. So let me write this as a limit. And let me add the and subtract. And then the last part, minus. Let me make it smaller. All divided by h. So the red color here is the tricky one. Okay, so you need to plus and minus with the some expressions. So the purpose for this addition and subtracting is to see whether it can change our function or not. Okay. And then I will grouping the some expression. So I will grouping the x plus h. Okay. So it will be let me write this as this group. Okay, and this is big, and plus the other one is gx. Okay, so this going to this and this. Okay, the arrow shows the grouping. Okay, so I can rewrite this form, the group of fx plus h and gx. Okay. And then I can write this as the first one here, and then the second one, all with the limit. And then plus, plug in limit, and write all the limit expression. Okay. And then what will happen here? And then we just solve the limit by put in the 0 inside the equations. So the first one, it became the f of x, right? And the second one, when you plug in 0 to here and here, remember that all of this is the derivative itself of g, right? The same thing, right? So I can write this as g prime x, okay, the derivative of g, okay. And then plus, this is just gx, and then the last part is the f1, so f prime, right? This is f prime. x is g prime. So I can write f prime x. Okay. So this is what we conclude in product rule. Or I can write f prime first and then g plus g prime f. Well, the same way if you flip. But I think I prefer to write the f prime first because it's easier to relate with the quotient rule. We will see quotient rule next section. So you need to add and subtract this fx plus h gx expression to get the g prime and f prime form. Okay. Any questions first? I think the product rule will be very useful for your tools. Okay. It will be also helpful in at least 1 year, okay, until the next calculus. You will also use the product rule often. Okay, we'll go to the next page for the quotient rule. Okay. And see similar, just using the big F to define f over g and use the limit definition. Change all the big F to f and g. Okay. And then solve this rational form. So it would be h, g, and then gx, right? Let me write gx first, and then f plus h. And then the other one, fx and gx plus h. Okay, similar to product rule, okay, we need to add and subtract some expressions. So add and subtract. In this case, we add and subtract the fx, gx. So gx, fx plus h, let me make it zoom. Minus, or you can say plus first, it's the same thing. Let me change the color. And then minus and then minus. Okay, so you get this form. Okay. And then grouping, okay, grouping the gx and fx. Okay, so this gx, okay, grouping with this minus gx, okay, and the other group will be fx, and grouping with the other fx. Okay, so another important thing, previously you remember that I also grouping the opposite signs, plus and negative. Why we need to grouping plus and negatives? The idea is to form the fx plus h minus fx over h. That's the derivative, right? So we need to achieve that form also in the quotient rule. So let's grouping. So first grouping the gx. Okay. The first gx, you have fx plus h. Okay, and then you are grouping with the minus gx from this part, from minus fx gx. So you can minus with f of x. Okay. Let me move the h. Okay. Let me change this h going here. Okay. So it will be goes here. Let me write h here, and we will have at the bottom we'll have a long line here. Okay. So first is gx, and then we minus this. Okay, with this second part of our equation, which is this minus fx gx plus h. Okay. So write fx, and then write the gx plus h. Okay. And we also grouping with the fx gx, the second one here. But because this is plus, it's already negative, so we are subtracting this expression with the with gx. And same h. And the bottom, we only have gx plus h gx. Okay. Maybe I will give you some notes here. So this A, this A, this B, B. Meaning you're grouping A with A, B with B, okay? And you will have this form, okay? And you are moving the H, okay? This H down here. So from here, so this H from here, you are moving to here, okay? It's actually like long line H like that, but I'm separating the rational functions. So you can see from here, you can see that the first one here, the f prime, right? And the second one is g prime, okay? And when you are solving the limit, plug in 0, it's let's just say gx, and then limit and then divide all, and also limit h going 0. Okay, so this one become gx, right? This one become f prime x. This one just become f of x, and the other one will be the g prime. Okay, and the bottom one just gx and then squared. So you can make a conclusion from here. The big f prime is, let me just write f prime first, okay, and then gx minus g prime fx. Okay, so I write the f prime at the first expression here because it will help you to relate with the product rule. Okay, so always start, my suggestion, this is just my suggestion, always start with f prime g. Okay, because this minus, if you mix up the f and g, then you will have a wrong calculations. Okay, so you need to have the f prime at the first expression for the quotient rule. Okay, let me give you a typical example and maybe how to solve some problem. Okay, but any questions first? Okay, any questions first? Okay, any questions? No? Okay. Um, we can go for some example, or maybe just one example, and then go for some trigonometry examples. Okay. So let me write some questions. Find equation of tangent line and normal line. To the curve y equal at, this is the point and this is the functions. Okay, so maybe if you remember how to solve, you can try. But here is the idea. Okay, so this is tangent line. This is normal line. Okay, so whenever you have this problem, tangent line, normal line. Okay, so tangent line, as you remember, if you have any functions, if you have just random functions like that, okay, your tangent line, it can be It can be in any point here as long as it is continuous. Okay. So for example, if your point is here, this red dot here, okay, maybe your tangent line looks looking like that. Okay. So whenever you cross the questions asking tangent line, meaning you need to have linear equations for this red color here, you need to find these equations. Okay. Okay. So tangent, you get the idea of tangent is actually the gradient, right? Okay. From our early calculus class, I already mentioned that the first derivative is your gradient. Okay. So if you have if you have uh, this is dy dx. So dy over dx, the rate of change of y with respect to x is your f prime, okay, your derivative. So if you have your functions is square root of x1 plus x squared, you need to find the first derivative, okay, and because it's already specified on this point, okay, 1.5, okay, so you need to plug in 1.5 to your functions, or in this case, just plug in the x equal 1. Okay. And because we already know the quotient rule, and this is rational expressions, then we can use our quotient rule. So this is f and g, right? So squaring the bottom part, and then let me write this as d dx of square root of x, okay, and multiply with the 1 plus x squared and minus if you want to write step by step, you can write the step this d over dx, the tools for derivative, but you can also directly just calculating the first derivative directly if you want. It's also okay. First derivative of square root of x is 1 over, right? And then this become 2x, right? Okay. Okay. Because we are asked to find the equation of tangent line, okay, you don't need to solve this until simplify. Okay? You don't need to necessarily simplify all of this form unless you are told to simplify. You can just stop here and just plug in the x equal 1 because you are told to just find the tangent, right? So you can stop here and just plug in the 1, right, from this point here, because the expression is only x, so we are only plug in the 1. Okay? Plug in 1. Okay? So this become 1 minus 2, 4. Minus 1 over 4. Okay? Okay, remember the questions, okay? So if the question is not asking to simplify any form, then if you can plug in the x easily, just plug in the x and you get the gradient or the tangent. So the gradient or the first derivative at x equal 1 is -1/4. So for the tangent line, we can use any linear functions, like you can use this one, or if you prefer the other one, that's also fine. Let's try the second one here. Because we have point half, right? And this is the x minus 1. So your y plus 1/4 plus 3/4. Yeah, let me write this bigger. Okay, so this is your tangent line. So tangent line equations, okay? Okay, but the question is also asking normal line. So what is normal line? Normal line, okay, if you have the graph, okay, if you have tangent line here, okay, at this point, okay, at that point also, you are having another line, okay, okay, that is perpendicular. So we have the perpendicular, okay. This is called the normal line. Okay. Maybe you remember in physics, you also have the same terms normal. Okay. The big N usually in physics. So the normal is always perpendicular to the tangent. Okay. And because of that, your normal line will be your -1/m. Okay. The negative and reciprocate, which means you need to switch the gradient. Okay. So if your gradient is -1/4, your normal line, your normal, okay, just say your normal is 4. Then your equations will be, and change the gradient into 4. Yes. And this is the normal line equations. Okay. Just a conceptual questions. And maybe until the next second calculus, this type of questions will be around. Okay, so you need to be remember what tangent line equation means, normal line equation means. Okay. Okay, let me move to uh, some essential functions for trigonometry and some proof for trigonometry. For example, the functions sine x. We want to prove the sine x. Same thing we need to write. Okay, we write all the limits. Just let me write the functions first. And you need to note that some property of trigonometry. Okay, sine x plus h, it will be sine x cos h. If sine, then it's plus, right? It's cos h, not the hyperbolic functions. Okay. In case you are mixed up with the hyperbolic functions. And minus sine. Okay. Remember, the blue color is just from the property of trigonometry, some identity, sine alpha plus beta, if you remember. Okay. Okay, and then we separate all of these functions. So I will grouping the sine x here with sine x. Okay. And I will move this here. Okay. And it will be sine x. This is cos h minus 1. Okay. Let me write the divide by h plus the cos x sine h divided by h. Okay, and still in the big bracket here. Okay, so let me separate with the limit sine x and then limit okay. This is sine x, right? And cos h minus 1 over h, this one. Have I told you before? The cos x minus 1 over x? Not yet? Maybe later. Should be equaling 0. Okay. This is from the idea is taken from the sine x over x. Okay. The sine x over x here, it's equaling 1. Okay. And this is equaling 1. Wait, it's not 1. The 1 is here. This is cos x. But because this is becomes 0, so your answer should be cos x. Okay. Okay, this part is actually, I think I don't remember if I have told you before. I think this one. If I have these functions with limit x goes to 0, I'm going to multiply with 1 plus cos x, and it will be 1 minus cos squared x, and this should be this, right? This can be sine x. Sine x, it's from sine squared. The other one here, here. This one become 1, and this is 0. So that's why it's 0. If you have cos x plus h, if you have cos x minus x, or minus 1 here, you have this, same thing. You try to multiply this, you get here, and I will write this as this, right? And the same thing with the negative, but because you will multiply by 0, it's the same 0, okay? Okay, get it? So it become sine squared x, right? And then forget you have the cos x plus 1 in bottom. So you will have minus, let me just write sine x over x and sine x over cos x plus 1. This become 1, this becomes 0, but because it's multiplied by 0, it's all becomes 0. That's why this becoming 0 here. So to solve this cos h minus 1 over h, first you need to multiply by the cos h plus 1. You get this expression, and you can minus this expression and becoming the 1 minus cos squared. So 1 minus cos squared is becoming the sine squared. You separate the sine x. Okay. The sine x over x, as limit x goes to 0, it's 1, right? It's 1. Okay. The other part, sine x over cos x plus 1. Plug in x is 0, cos is 0. This is 1 plus 1, 2 over 1, 2. 0 over 2. It's 0, right? And because you are multiplying with 0, all of this result will be 0. So that's why here you have 0. Okay. Okay. Any questions? So the conclusions, as you may know and familiar with, your f prime x, okay, or in this case just f small f, is cos x. So if you have sine x, then it will be just cos x. Same thing with the other basic trigonometry. I will just write several examples. I will not to prove all. If you want, you can try by yourself. So first is the sine x is cos x. You may choose to memorize or not. It's up to you. Okay. I think just the basic one is fine, and you can actually derive the other one with the basic one. Secant, yeah, I think just this 4 is enough. Okay. Cosecant, cotangent, not really important. Okay, the next one is the chain rule. Okay, so I think I will give you more content, and then maybe after several basic derivative tools, we can start several examples, and yeah, and you can have exercise. Okay. Okay, any questions? For online students, do you have any questions? Any questions here? Okay. Okay, you can come to me after class if you feel confused. Okay. Chain rule. Do you want to have 5 minutes breaks or just continue and have early finish or break? If you want to break, we can have just at 12, I will finish the class. Or if not, then we can continue, and maybe 5 minutes before 12, we can also have finishing our class. If you want to break 5 minutes, continue, continue. Is that okay? Okay. Okay, chain rule. Let's just say we have the functions h. Let's say this is sine x squared. Okay. Okay. I just want to know whether you are already familiar or not with the chain rule. What is the first derivative of the function h? So you have sine x and then squared. And what's the first derivative? Any idea? Okay, any idea for sine x squared? Let me make it bigger. Okay, sine x squared. Sine to x. Sine to x. Okay. Any idea? 2 sine x. And then? Okay. Any different answer from that? Okay. Okay, just to make sure your background. Okay. Uh, 2 sine x and then cos x. Yeah, this is the correct answer. Okay. So the idea of the chain rule is you have more than one functions combining into a big functions. Okay. So for example, you can see this as you have two functions. Let's say you have a, okay, a squared, and you have sine x. Okay. You have the dA here. It becomes 2a, and you have the ddx here becomes cos x. Okay. And because a is sine x, it's become 2 sine x cos x. Okay. So I can write this as d dx of the sine x the sine x squared d sine x. Okay. And d sine x over dx. Okay. So your sine x become your variable in this case. Okay. So you can also, but if you want to make it like a, that's also fine. So if you want to make a here, that's also fine. Same thing. But you can write as these expressions, the chain rule expressions. Okay, so if you have the combinations or composite functions, f gx, so the g is inside the f. You can write this as f prime with g inside and multiplied by the g prime itself. Okay, some mistakes is if you forget this, the blue one here. It's the case. Sometimes forget to add. Okay, so you need to be careful. This is composite functions. Composite. It's not the product rule. Okay, it's composite function. Okay, just introduction to chain rule. You can also write the chain rule if you have dy dx, dy over maybe du, and du over dx. You can write also like this. Okay, you can have other variable u here, but it's likely similar case with this a here. Okay, and you can have as many as you want. Okay, you may be having more than one variable here. So the composite is not just two functions, it's maybe more and more. And it is nesting. So du over du over dv, dv over dw over dx. Okay. You can have as many as you want, okay, in chain rule. So it's like functions inside of functions inside of functions, and so on and so forth. Okay. Finish this part. Okay. So I was also wondering, okay, maybe if you know the news, have I asked before? Um, I read the news. There are school teachers. The teacher gave this problem. Have I asked before in this class? I forgot. So you have A, B, C, D, E. You multiply this 5-digit. So A, B, C, D is a 5-digit numbers. You multiply this with E. It becomes a 6-digit E. Questions is asking all the number exactly. Do you know? I read the news. It's in Taiwan. So the teacher give to 9-year-old student to solve this. Just for your information. But can you solve this? If you have this question, can you solve? Any idea to solve? Any idea to solve? Okay, if A, B, C, D, E is all just say integer. Okay, of course it's integer because it's a digit and it has no negative number. It's all positive number. So the key to solve this problem is here. E becomes E. Okay, you have 1, 2, 3, 4 until 9. Okay, and 1, 2, 3, 4 until 9 also, right? So you need to choose any number that when you multiply that with the same number, it becomes the same number. Like 1, it's 1, 1, 1, right? But I don't think 1 will be our choice because it will be 1, 1, 1, 1, 1, 1, right? It's 1, 1. If you choose any number from A, B, C, D, I think 1 will be not your choices, right? And then what else? What number? 2, 2 is 4, right? 9, 16, or maybe 5. Or 6 is 36. It has 6, right? It has also 5 here. You can also use 5, 5, or 6 if you want. 5, 5, it should be 5, and you still have 2. So DE plus 2 is another 5. And you can have several equations, and you can solve it by the time. You can try at your home if you want. Okay. I'm not sure why the teacher gave the 9-year-old this question. Okay, let's continue our subject. Okay, for calculus, if I have the square root of cos x, what will it be? So first, okay, to our understanding, we can try to figure or try to find the composite of the function. So for example, you can write this as your f with g inside. Okay, So you can have the idea that your f is just this big X, right? And your gx is plus X. You can write like this and solve one by one and chain all together. Or if you are familiar to just directly solve, then just directly solve, that's fine. Okay. Making the, for example, the dy dx, dy over du, or directly solve, I think it also depends on how complicated the function is. Okay. This part here, when you're trying to this form dy over dx, dy over du multiplied du over dx, this will help you in at least 1.5 years. Okay, you will learn this subject in differentials form. Also in engineering math, you will also encounter this one. And if you have more than one variable, okay, so all this semester we only have y and x, so you only consider one variable. Okay, in next calculus, the content is all the same, but the difference is you have multivariable, so you have more than one variable. So for example, x, y, and maybe z, maybe the maximum maybe three variables at most. Okay, and now we are only learning in one variable. Okay, to derive in one variable. So you can also write in this form like this one, or you want to write one by one. You need to define your f, your g, and then finding f prime, finding f g prime. This also can be done, and you will have your answers. Okay. But if you want to just directly derive, because it's not too complicated, you can also do that also. So it will be this, right? And multiply by negative sin x, sine x. And yeah, this is your answer. But if you want to one by one, f prime is 1, and g prime is the negative sine x, then you can plug in the negative sine x, put back into the equations. Let me check. Okay, maybe I can start to go to the exponential, okay, the exponential functions. So I would rather to have most of the basic functions, like the power rule and all the rules, the trigonometry, and then maybe exponential and logarithm. Maybe we can go directly all those forms, and then later we will have some examples. Okay. So exponential functions. So if you have y, it's b with the power of x. Okay. Or you would say f of x if you want. Let's say our first derivative. Okay. Write all the limit definition. Change all to our functions. Okay. In exponential, you can write this x plus h. You can write this like that. right? You can write like this, and you can factorize b with the power of x, b with the h, and minus 1. Okay, let me write this as px here. Okay. So we have these expressions here. Okay, bh minus 1 over h. Let's say b is any number between 0 or maybe negative number also, maybe just positive number. We can say b can be 1, 2, 3, etc. Okay, to get your understanding here, let me just use the number 2. So 2h minus 1h. Okay, let me use some trial and error for some number. This is h. Okay, so as the h, for example, 0.001. Okay, you plug in this number to h here. Anyone bring calculator? Can you make sure 2 with the power of 0.001 minus 1 and then divide by 0.001? What number you get? You get what number? 0.6933. Okay. 0.6933 something, right? And one more time, let's try 0.001. Let's try the 0.00001. Okay. This is some rough confirmation or roughly proving our limit. Okay, because limit is reaching 0. So let's try any number closer to 0. Maybe 0.001, 0.00001. Okay. 69315. Okay, and you can also try the -1, and we will bring similar number, 69 at the front, 29, blah blah blah. Okay, and I don't have time to prove further, but let me just show you that. Can you type in your calculator ln2? 6931, right? It's similar to our number. And in fact, this is actually the log of natural base of 2, which is 6931. Okay. This is if your b is 2. Okay. So if b is 2. So if b is 3, you can do the same thing. Okay. And you will get some number which is ln3, which is ln3 is around 10861. Okay, so there will be, okay, this is just roughly proving. I will later show you the theorem. There will be some number, okay, some number in between these 2 and 3 that will be equaling 1. Okay, there will be a number here. Okay, there will be a number here. This black color here, the black circle here, that will be equaling 1. Okay, so this number we call the E. Okay, as in it is in the our base of natural logarithm. Okay, this is just roughly proving the E through some trial and error. Okay, next time I will try to find to prove, but you have E here. Okay, you have your Euler number. Okay, so your E is let E be the number, so that okay, this is the definitions. Okay, you can have the definition from the exponential forms. Okay, you can also have the E from another form. You can have also the E from limit as n approaching infinity 1 plus x over n, and it's e to the x. You can also write this as 1 plus x 1 over x. This is E. Or you can have a limit this is also E. You can have several forms for E, but let's say that our E is any number that when you see any exponential growth, okay, in any populations, okay, like in bacteria, human, animals, and so on, you will have some number, okay, in that particular cases, which is E. So E will be our natural number. So we say natural number because we can prove E from nature. Okay. Let's just go to our definitions. So from here, this bx here, so f prime x of all the exponential will be b with the power of x, and this is ln b, okay, from our solution here. Okay. And that's why when we have e to the x, when we derive, we will have just e to the x. Okay. So if we have Okay, sorry, online students. I will share the screen. Okay, let's continue a little bit. So if you have your functions is e x, okay, to the x, your f prime x will be actually e to the x, and you multiply with ln e, which is just 1, right? That's why your derivative is e to the x. Oh, by the way, e is somewhere between 2 and 3, which is 2.71828 something. Okay, so exponential functions. And the other part, because I already introduced e, we can go for some logarithm. Okay. So if you want to write up this, I think this is important here. If you have the exponential here, and I think this is also e to the x. You're already familiar with in high school, I think. Um, Another is ln x. But maybe I will uh, give to you next Monday for the ln x. We have now 1140. I have some examples for the derivative part, but let me just go to. Okay. Um, okay. Draw a diagram showing two perpendicular lines that intersect on y-axis. Okay. Let me. And both lines are tangent to parabola. Okay. So the question is, after you maybe draw the diagram, where is the intersection of these lines? So it will be intersect on y-axis. Okay. And which point on those axes? Okay. Can you solve this one? If you can solve it, I will give you a bonus point and maybe check. Okay, maybe some gifts for you. Okay, we have around 15 to 20 minutes to solve. Okay. If you finish the questions, okay, if you finish the questions, raise your hand. Okay. So draw a diagram showing two perpendicular lines. Okay. So two perpendicular lines that intersect. Okay. That will be crossing each other on the y-axis. Okay. And both lines are tangent. Okay. So this is tangent. So the perpendicular line is a tangent to just a parabola x squared. The question is where is the intersections of these lines? Okay. What is the point of the intersection? Okay, first thing first. Okay, do you understand the question? That the first thing. Okay, so the idea is you draw first the x squared. Okay, draw the x squared. Imagine there is a line. Okay, two lines. on the x squared. Okay, those lines are a tangent to the x squared, and the lines will be crossing each other, making intersections. So like x, like that. And the question is asking at what point these lines will be intersection. At what point? Okay, it's just x squared, and it's just a tangent. Okay, yeah. So just that, just that information. Do you think you can solve it, or it's like impossible for you? Figure? Yeah. The run at zero. No, not zero. At x equals 0, the tangent will be 0, right? Tangent is If tangent is 0, then the line will be horizontal. So it's not possible to be 0. Let's see. Okay. So first, you have two perpendicular lines. Okay. Those two lines will be intersecting on y-axis. And that line also tangent to parabola x squared. Okay, so the idea is first draw the parabola first. Just easy x squared, right? Simple x squared. Imagine you have a tangent, and then the tangent is crossing each other at the y-axis. Yeah, good, good, good. Yeah, like this. Yeah. Okay. And then. Okay. So you finish? Okay. Do you understand the equation? Okay. So actually, the equation is you have the x squared. Yeah. Mm-hmm. So you have the parabola x squared. Yeah, x squared. Uh-huh. Yeah, and maybe here also. Yeah, from negative. Yeah, and then there will be 2 points here. When you are having a tangent line, it will be crossing in this point, tangent line. So exactly at this point, and this also maybe here. Yeah, yeah, and this also intersecting here. Okay. Yeah, yeah. So to find this point. Okay. Yeah. Good. Good. Okay. confused with quotients, or yeah, it's perfect like this one. Yeah. Did you understand the question? Okay, so if is it better if you draw the x squared like the parabola like this? Okay. Yeah, and then you have two lines. These two lines is a tangent. So a tangent means it will be maybe in here or in here, and it will be having like this, that line, and that line will intersect in the y-axis. Mm-hmm. Yeah, maybe like that. Yeah. Yeah, and the other one is here, also the tangent line. Mm-hmm. So which point? Uh, for sure, half and 1/4. This point. So x is half, y is 1/4. If x is, if I have x here, it's 1/4, but it's only 1 point, right? Can you draw the tangent line? Okay, almost. Finish? Okay, good. And then your add the number later, okay? Okay, one students finish the questions. Okay. To commemorate, so give this. Okay. Okay. Let me just explain a little bit, but maybe not solving all the questions. So, okay, the idea is drawing the x squared. Okay. Yeah, maybe that is our x squared. Later, we pick a point maybe here and here, so that when we have the line, we are having a bad line. Yeah, just not good. Yeah, okay. So imagine this is the tangent line. This is also the tangent line here. And you need to find this point, okay? You need to find this point, okay? First is you have y equal x squared, okay? You find y prime to x. This is for your gradient, right? And then the other part is you have the perpendicular lines. Meaning if this is m1, this is m2, m1 multiplied by m2 is -1. Like the first is tangent line, the other is normal line, a similar like that. Okay, you have this idea here. Okay, and then remember, it will intersect on y-axis. Okay, so intersect on y-axis, meaning x is 0 there, right? So if you have this is a and a squared, right? This is -a squared, right? This point. And then you plug in all making the tangent line equations, okay, and then making x is 0, you will get the intersection is 0, 0 and -1/4. Let me check if I have right all the answer or not. Oh yeah, I've write the answer. So like this. So just make any variables a, and this is -a. You have the first derivative, okay? Check all the line equations, okay? And then when x is 0, your line is just -a squared. And check with the positive a. So this is your positive a. The same thing, 0, -a squared, okay? And then because it's perpendicular, so a squared is 1/4. That's why the answer will be 0 and -1/4. Okay. Okay, I think that will be our last section for today. So class is finished, and I hope, okay, I hope you can maybe not exercise all the questions in the textbook, but you can see the questions first. Okay, try to understand the questions first, because you need to first you need to understand the terms, and you need to understand what is basically the question is asking. Okay, like these questions is, I think it's like typical questions in calculus. Okay? Asking the tangent line, asking the whether the intersections, perpendicular, etc. Before you're trying to solve with all the formula calculus, try to understand the question first. Okay, that's just my suggestion for you. Okay, do not try to take all the questions, but try to get the idea for the questions first. Okay. Okay. Class finish. Also the online students. Yeah. Yeah, Brian, you got it correct. But it's unfortunate I cannot give you any prize because I gave some snacks to the students in the class. Okay. Okay, online students, you can leave the uh, online meeting. We finished the class. Okay.